So what we're going to do is we are going to solve for sine x. So the first thing I would do is I'd add 1 to both sides, then divide by 2, which would give me with that sine squared x equals 1/2. Now when I take the square root, when you are the one taking the square root, you have to use positive or negative. So when I take the square root of it, we're going to have sine x equals positive or negative square root of 1 over 2, which is really 1 over square root of 2, which means you'd multiply the top and bottom to get positive or negative square root of 2 over 2. As soon as we have that positive or negative, we know it's in all 4 quadrants. So what I said yesterday is just locate what your first angle is. What is the very first angle in quadrant 1 that would give me square root of 2 over 2 for sine? Yeah. Pi over 4. Yep. And now I could just go down the line for all the other quadrants. Quadrant 2 would be 1 less than our denominator, so that'd be 3 pi over 4. Quadrant 3 would be 1 more, so that's 5 pi over 4. Realistically, quadrant 4 should be the only one that you have troubles with. And if you didn't quite have it memorized, you can always do the trick that to get from 1 to 3, you had to add 2. So to get to 5, to that next number, we would also add 2 to give me 7 pi over 4. It's just a trick in case you don't have it memorized. It's always good to have multiple ways to get something in case on the test you forget one way, then you have another way to get that value. All right, questions on the bell work? Okay, then let's go over questions from the homework. Lydia. Oh, cool. It's one of the ones that wasn't on there. I don't know what offhand. Is it secant?
It's 3 cotan squared x minus 1 equals 0.
I'll say that one more time. It's 3.
3 cotangent 2x squared x minus 1 equals 0.
So just like that?
Yeah.
Okay, so we would add 1 to both sides, divide by 3, take the square root, so we'd have something like cotangent x equals positive or negative. And it looks like I'd have square root of 1 over 3. Is that looking like yours so far? Mm-hmm. All right, to turn it to tangent, I would not simplify that. All I would do is, okay, tangent x would be plus or minus flip it, so it just becomes square root of 3. Is that good so far? Okay. So then I'm asking where is tangent equal to plus or minus square root of 3. So we find in the first quadrant, it's going to be square root of 3 at pi over 3. Mm-hmm. So then my second quadrant would be 2 pi over 3. My third quadrant would be 4 pi over 3. That looks like it took 1 to get there, so we're going to go 1 to the next one, so we'd have 5 pi over 3. Good? Cool. All right, other questions from the homework? Yeah. Number 12 was exactly the same thing as number... It's the exact same problem as 4 cosine squared minus 1. Number 2. 2 and 12 are the exact same question. That's why I meant to change it. It just didn't get... 12 and 4 are the exact same problem. So in theory, you have the exact same answer. Am I wrong? Because I don't have mine.
No, you're correct.
Okay.
I just
Didn't do it the same way the second time. Once your brain gets tired. All right, other questions? Oh, yeah, Peter. 9. Niner. Niner was secant squared minus 1 equals 0. So the first thing we do is we solve for secant. No, that's blurry. Retake that. Retake, I says. Use that one. All right, good. All right, so we had secant squared minus 1, so I added 1 to both sides. It came out secant squared equals 1. Take the square root, it just becomes plus or minus 1. Well, secant we don't have on the unit circle, so we're going to turn it to cosine, which means we're going to take the reciprocal of it. So this is 1 over 1. Reciprocal of 1 over 1 turns back into 1 over 1. So we did take the reciprocal. You just can't see it because it just turns from 1 to 1.
Yeah.
Then we're looking for cosine equals a positive or negative 1. That's in 2 locations. So where is our x value equal to a 1 or a negative 1? That's going to be at 0, and it's going to be way at pi as well.
Oh, okay. I said it's 2 pi.
So we can't use 2 pi because if you look at the directions, it says it's bracket 0 and a parenthesis 2 pi. So we can include 0, but you can't include 2 pi. So technically, although it's correct that it equals there, I exclude it because that's not what the question asked for. It asked strictly between 0 and 2 pi, not including 2 pi.
Okay.
Okay?
Yeah.
All right, other questions? Yeah.
Number 10.
Number 10 gave us cosecant. So it looks really complicated at first, but we have to stick with what we've been doing the whole time, and that is moving all of our trig to one side. That is our goal on all these, is to move all your trig to one side and then see what you need to do. So before I do anything else, I need to move this over here. I'm not going to use division or anything. I'm just going to straight up subtraction. I'm going to subtract this from over there. And then once I have it all on one side, then I'm hoping I can do something. And in this case, we have cosecant and cosecant in both of the terms. So I'm going to lift and bring it out front. So that's going to give me cosecant out front times, well, we carried on that 2. This secant got pulled out front, or cosecant, so we're going to bring that secant down. So that gives us 2 possibilities. Either cosecant equals 0, or 2 minus secant equals 0. For cosecant equaling 0, well, that doesn't exist because I'd be looking for the reciprocal of 0, which would be something over 0, which does not exist. For secant, we'd have 2 equals secant, so reciprocal of 2 is 1/2. I'm looking at where cosine equals 1/2, and that's pi over 3 and 5 pi over 3.
Thank you.
Yeah.
For that same problem, we divide cosecant from left side. I go to the right side too.
Can you divide it?
Yeah.
You're dividing cosecant?
Yeah.
So if you divide by cosecant, your cosecant would cancel out, and you'd be left with secant equals 2.
Yeah, so wouldn't that just be it?
Well, that's going to give you one answer, but it won't give you the other answer. It just so happened that this one doesn't exist. That won't always happen. So what you do when you divide both sides by something is you get rid of a possible answer. So a good example of that might be just with x's. You can never just divide something out to get rid of it. So let's think about x squared equals x. All right, one route is your route where you just divide by x. That's going to leave me with x equals 0. It'd be x equals 1. If I would just divide both sides by x, right? Well, if I do it the other method, the correct method, and I subtracted x from both sides, I'd have x squared minus x equals 0. Factor out an x, out of x times x minus 1 equals 0. I agree that x equals 1 is one of the solutions, but another solution is also x equals 0. This method doesn't show that 0. So when you divide, you're eliminating one of your possible zeros to look for. In this case, you would have got it right because the other 0 didn't exist, but that's not always going to be the case. All right, other questions? Okay, then let's go over to today's notes. The good news is today's notes, if you understand what we did yesterday, today's not going to be a big leap for you because we're still looking for those angles. Today, though, yesterday we said we limited it from 0 to 2 pi. So I was just looking at each quadrant where we had that value. Today we're looking at forever. What forever tells us is if I find an angle, I'm allowed to add 2 pi to it. I'm allowed to subtract 2 pi. I'm allowed to subtract 2 pi, 2 pi, 2 pi because they're coterminal angles. So we're now going to list every possible value that's in that same spot. So how that's going to work? Well, we're going to start the exact same way we did yesterday. We're going to go, okay, cosine x equals square root of 2 over 2. Well, the first thing we might want to look at is where is cosine positive? Cosine's positive in quadrant 1. Cosine's positive in quadrant 4. It is negative everywhere else. So we should at least think about that. All right, then we're looking at where, I usually look at first quadrant. Well, where does that equal square root of 2 over 2? Well, that equals it right here at the old pi over, not 2, but pi over 4. Well, in quadrant 4, it has to be in pretty much that same location where we're going to have something over 4. We just have to remember what goes above that, and that is 7 pi over 4. Thank you. So yesterday, I would just put x equals pi over 4, and I'd put x equals 7 pi over 4, and that would be it. Well, today I want every possible answer. I want all real numbers. So what I want is pi over 4 plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi, but we're not going to just sit there and write every possible because that would take eternity. Instead, when they ask for all real solutions, we're going to use something called set builder notation to list them all in one fell swoop. And set builder notation starts with a brace. It starts with a brace, and then we're going to put an x, a vertical bar, and another x. In math, an x with a vertical bar with an x after it is red. All solutions such that x something, something, something. So we're saying x such that x equals something. So right now we're going to say x such that x equals pi over 4. That would be one answer. Well, I want to include all the ones where I add 2 pi and subtract 2 pi. So we're going to set up an equation. We're going to say x such that x equals pi over 4 plus, well, I want to add 2 pi over and over and over. So we're going to go, well, it's plus 2 pi times some variable k, where k is an integer. And then we're going to end the brace. We are going to assume in this whole chapter, every time you use k, it's an integer, so you don't need to write that down. All right, from here on out, we're going to assume k is an integer. This now says pi over 4 plus 2 pi times any k value. So that could be, your k could be 3. That would be 6 pi. That would be a coterminal angle. K can also be negatives. So we're handling if we're subtracting 2 pi as well. So what we're doing is we're saying, well, is pi over 4 plus or minus any variation of 2 pi. So this is all possible solutions where we end up right here. All right, now we have to do the same thing for this one, but the setup is the exact same way. We're going to put a little or between here. Or we have x such that x equals 7 pi over 4 plus, and traditionally you put the k between the 2 and the pi, but it really doesn't matter where you put it. Oh, no. That's a sad day. Now it's got character. All right, so normally we put the k in between. I don't care where you put it. It's multiplication. It's all the same. You could write k times 2 pi. I do kind of like the 2 pi times k just because you recognize why we have 2 pi. It's for coterminal angles. So don't worry about where you put the k. That's it. That's our entire problem when they want all solutions. There is another way to rewrite this, and I'm going to do it down here. There's a way to put this inside of this brace, so you just can do one brace. Either way is a completely acceptable way to write it. So we're going to do it a slightly different way down here, but it's still the same idea, where we're looking for where sine equals negative 1/2. Well, sine is negative in quadrant 3 and quadrant 4. It's positive in quadrant 1, and it's positive in quadrant 2. So really, we're looking for values that are in quadrant 3 and 4. Me personally, I first look in quadrant 1 so I know what is going to be on my denominator. So just for the sake of using reference angles, in the first quadrant, where is sine equal to 1/2? Or what angle is sine equal to 1/2 in the first quadrant? It's pi over 6. So that means our two places are going to be something over 6. And this one will be also something over 6. Well, to be in the third quadrant, we have to be 7 pi over 6. To be in the fourth quadrant, we're going to go 11 pi over 6. I'll talk about this again. There is another way to figure out what in fourth quadrant. You can also double your denominator and subtract 1. That works for all of them too. So 6 times 2 is 12, minus 1 is your 11. That's another way you can get to your fourth quadrant. All right, so those are our two angles. They want all real numbers, so we have to use set builder notation. So we're going to go with x such that x equals, and let's list our first angle first, so that's 7 pi over 6, plus our 2k pi. And in the same brace, I'm going to put an or. So after that 2k pi, I'm going to put an or. And then I'm going to put my other one where you have x equals 11 pi over 6 plus 2k pi. Either you write it the way above, or you write it this way. I don't care. They're saying the exact same thing. This way is just a little shorter into two braces, I guess. So you can write it either fashion you want to on your homework. On your answer guide, I think I primarily just used this long way. This one where I write it all out at once. But know that both ways mean the exact same thing. Our next one is tangent. Tangent's special. Tangent is special when we do these types of things. And we'll see why once we put it down and we do some work. All right, we have tangent x equals 1. Well, tangent is possible, or is positive, in quadrant 1. It's negative in quadrant 2. It is positive in quadrant 3. And it is negative in quadrant 4. Well, tangent equals 1 right at pi over 4. If we shoot straight across, that's also where it equals 1, and that is 5 pi over 4. So there is right now a really long way to write this, or there's a really short way to write it. We're going to write the long way first because it looks just like the sine and cosine. So the really long way to write this is we could write x such that x equals pi over 4 plus 2k pi. That handles this angle and every angle coterminal to it. Or the other angle, which is 5 pi over 4, plus 2k pi as well. That handles my second one in any version of adding 2 pi or subtracting 2 pi. There's a much easier way to write this. Does anyone see the easier way to write this so you're still covering all the same angles? Yes. We can just add pi. These are directly across from each other. So you are allowed to, if I take pi over 4 and I add pi to it, I get back there. If I add pi again, I get back to my original angle. We could also subtract pi and cover all of our angles. So a short way to deal with tangent, maybe we'll just call it the short method, is to just write it as x such that x equals your first angle, pi over 4, plus k times pi. I'm either adding or subtracting pi a whole bunch of times, and I'll get to every single angle that we have. This will always work for tangent, except for our undefines and our 0 areas. And this method will also work for cosine and sine when you are looking at, so think of the sine of 0. The sine of 0 happens at 0 degrees and at pi. Those are directly across from each other. So that answer could be something like 0 plus k pi, because adding pi gets you. So anytime you have angles directly across from each other, you can shorten it to just pi. That works for almost all tangent values. Most sine and cosines you have to write the long form. It is only if their angles are directly across. Yeah.
What happens if like sometimes in the homework last night we got x equals positive or negative an answer?
Mm-hmm.
How would we write that?
So you have to write it for each one of them. Actually, so think about if it's positive or negative.
Could you just write plus half?
We're looking at 4 different angles, right?
Mm-hmm.
So let me just talk about that, because that could crop up. So if I'm looking at a unit circle and we're doing, I want every possible one, right? So let's say we're talking about all 4 of these points. Well, we don't have to do 4 equations. We don't have to do 4 equations because this one would just be adding pi to get to here. So rather than adding 2 pi, so say this is pi over 6, instead of plus 2 pi, I would just go plus pi times k takes care of both of these. Then in my second formula, I would take this one and go plus pi times k, which would take care of this one. So you could still only do it in 2 formulas versus having to write all 4 of them. But there'd be nothing wrong if you wrote all 4 of them as being the 2 pi times k. You'd still have the correct answer. It just takes a lot longer. Does that make sense? Okay. All right, the last thing we're going to talk about are equations with multiple angles. This is by far the most missed question on the test every year. And it's because of where you deal with this 2 alpha. You're going to deal with this 2 alpha at the very end. In fact, we're going to forget about this being 2 alpha. And if you look at my first, this isn't the only way to do it, but a good way to look at it is pretend like you don't have 2 alpha. Pretend like you have just regular x in there. So what we're going to do is we're going to go, you give me 2 alpha. I see your 2 alpha and I raise you an x. We're going to replace 2 alpha with x. All I want you to do is recognize that if I give you square root of 2 sine of 2 alpha, we're really treating it as just sine of x equals 1 and doing all the same steps. We're not going to deal with the 2 alpha until the very end. So we're going to treat this just like any other problem where we solve for the sine and we figure out what angle gives you those values. So in this case, we're going to divide both sides by square root of 2. Note, did I take the square root? Did you take the square root of both sides? No. You were given it, so it's not positive or negative. It is just whatever sign's in front of it. So don't just every time you see a square root put positive and negative in front of it. It's just if you physically took the square root of it. So we're going to divide both sides by square root of 2, which would give me sine x equals 1 over square root of 2. Multiply top and bottom by square root of 2, and we have square root of 2 over 2. So that gives us 2 possible x values. What are our 2 possible angles that will result in square root of 2 over 2 if I plug it in for that sine? Yeah, okay. Yeah, pi over 4 and 3 pi over 4. So that means if I was asked to do all of the answers, we'd go, okay, x equals pi over 4 plus 2k pi. And we'd also have x equals 3 pi over 4 plus 2k pi. All of that work is still sound. This is the first step where I care that is 2 alpha. So what we're going to do in the next step is we're going to put this 2 alpha back in place for that x. And then we're going to solve for alpha. So what we're doing right now in our next step is we're taking that 2 alpha and we're plugging it in for those x values. That will then get us underneath this, which will give us 2 alpha equals pi over 4 plus 2k pi. And we're also going to have 2 alpha equals 3 pi over 4 plus 2k pi. I'm going to copy and paste that on a new slide, so it'll disappear for just a second, and then it's going to come right back up. Now we have to solve for alpha. So we need just alpha equals something. To get just alpha equals something, we need to divide both sides by 2. So we're going to divide everything by 2. So I'm going to divide everything here by 2. I'm going to divide everything here by 2. And that's going to give me alpha equals pi over 8 plus k times pi. Over here, we're going to have alpha equals 3 pi over 8 plus k times pi. Now we're going to rewrite in that step builder notation. So we're going to have our brace alpha such that alpha equals pi over 8 plus k pi, or alpha equals 3 pi over 8 plus k times pi. So let's go ahead and put that underneath. So our end answer in step builder notation is alpha such that alpha equals pi over 8 plus k times pi, or alpha equals 3 pi over 8 plus k times pi. So this is the most missed problem because people just don't know when they're supposed to divide by 2. They'll actually start the whole problem by dividing by 2, and then we're going to get an angle that's not on our unit circle. So dividing by 2 happens at the very last step. Right when I could have written it out, then go, oh, I should have divided everything by 2. All right, we're going to do this exact same thing one more time because I do think it's important and people miss it. So we have tangent 3x equals negative square root of 3. So what we're actually looking for, do I want to put an x in place of there? I guess I'm going to let it equal a. So we'll go 3x equals a. So that's going to give me tangent a equals negative square root of 3. I just want to get in our mind that we're still just looking for where does tangent equal negative square root of 3. That's all I want us to recognize. I'm just looking for where is tangent equal to negative square root of 3. So that's where alpha or a equals, what 2 angles are those? Did you give up or do you want to try it? Do you know one of them?
Yeah. 5 pi over 6 and
5 pi over 6.
11 pi over 6.
It'd be correct if I was looking for square root of 3 over 3. Square root of 3 over 3 is our first tick mark.
Right. Well, no. Over 3, right? 3 pi over...
Yeah, over 3. Yeah, there you go. Okay, so let's go with that.
3.
So we're going something over 3, right?
Yeah.
And something over 3. So what's the first quadrant where tangent's negative?
Yeah.
Second quadrant. So how do I make this second quadrant right here?
2.
With a 2. There we go. And then what's the last quadrant we're negative in for tangent? 4. How do I make this in quadrant 4? 5. Yeah, that's it. So we have 2 pi over 3 and 5 pi over 3. All right, so that's going to lead us to 2 possible equations, but we're going to have to change them. So we're looking at a equals 2 pi over 3 plus 2k pi. And we're also going to have a equals 5 pi over 3 plus 2k pi. But our a was really in place of that 3x. So we're going to have 3x equals that 2 pi over 3 plus 2k pi. And we really have 3x equals 5 pi over 3 plus 2k pi. Could we have shortened that at all? How? What was that? They're right across from each other. They're right across from each other, so we could have just had pi. We could have just had pi. I'm going to finish this way, but know that this could have been a lot shorter. We could have just said 2 pi over 3 plus k times pi. Okay? Know that this could have been shorter. If you want to put it in your notes as shorter, awesome. I'll probably do it underneath. But if I'm just going this way, we're going to then have our x such that x equals, dividing everything by 3, we'd have 2 pi over 9 plus 2k pi over 9. Or we'd have x equals 5 pi over 9. Oh, I'm sorry, it should have been over 3. 2k pi over 3 because we divided everything by 3. Then we'd have 5 pi over 9 plus 2k pi over 3. So all I did is I divided everything by 3, which gives us 2 pi over 9, 2k pi over 3, 5 pi over 9, 2k pi over 3. Or, like Karina noted, we could have done this. The simplified version would have been, so this would probably be the easier version. We could have recognized that 3x could also equal 2 pi over 3 plus k times pi. So they're right across from each other. Which would have then given us x such that x equals 2 pi over 9 plus k times pi over. Both of those are the exact same answer. This one's just a little easier. If you're like, oh, tangent values are straight across from each other, combine these two into just one, where you take the first angle and you add pi to it. Is there something wrong?
No, I was.
Do you have a question?
Yeah. E and easier. Ace here.
Did I spell it wrong? What was that?
That was a bracket.
Oh, okay. Oh, yeah, it just was dots. It didn't quite, I gotcha. I corrected it. All right, other questions? Okay, that's it. That's all you're doing in your homework. So it's basically just an offshoot of what we did yesterday. So hopefully maybe there's a couple tricky ones, but hopefully you get what we're doing at least.